Exercise 9.1, Algebraic Operations, Part 1, Elements of Algebra. We're going to start out with some vocabulary that you're going to need to be familiar with. A term is an expression containing one or more letters or numbers. Examples of terms are 2, a constant term, is a number just by itself. M, a variable. 3m, made up of a coefficient 3 and a variable m. xy, multiple variables, 6 and m. Each one of those individually could be a term. An expression are terms that are grouped together by addition and or subtraction. Here's 3 examples of expressions. 2x plus 3y minus 6 is an expression. It's an expression with 3 terms. The reason that we know that it has 3 terms are they're grouped by addition and subtraction. So there's a term, and there's a term. Terms are always separated by an addition or a subtraction sign. 2ab minus 14b. There's a subtraction, so this is 2 terms. 3x cubed minus 2y cubed, 1 subtraction symbol, 2 terms in that expression as well. So terms are separated by addition or subtraction. We can count up the total number of terms in any expression pretty easily by looking for the addition or subtraction symbols. Some more vocabulary. Rational expression. Rational expression, remember rational means fractional. So a rational expression is a fraction containing variables. Algebraic expressions are classified by their number of terms. Terms, remember, are separated by addition or subtraction signs. And a polynomial is an expression with more than one term. Going back to the first bullet point, expressions are classified by the number of terms. A monomial, the prefix mono means 1, so a monomial means that there is 1 term. An example of that would just be 2x. A binomial, prefix bi means 2, has 2 terms. 3m plus 4 would be an example of a binomial. Trinomial would have 3 terms. 2x squared minus 4x plus 5 is an example of a trinomial. Adding and subtracting like terms. We've talked already about radicals and how radicals have a lot of the same property as far as addition and subtraction goes as variables do. The only way we can add or subtract radicals are if they are like radicals, where the index and the stuff underneath the radical matches exactly. Same thing when we're talking about variables. To add or subtract algebraic terms, they must be like terms, meaning that the variable portion of each term must match exactly, not just the variable, but also the exponent on the variable. In other words, x and x squared are not like terms, even though it's the same variable. We do not have the same power or exponent on that term. Once you determine the terms are like terms, you add or subtract the coefficients and keep the variable portion the same. The coefficients, remember, are the numbers directly in front of the variable portion. So here's some examples. Let's look at the like terms first. Each row here represents like terms. 4y squared, negative 3y squared, root 3y squared. All of those are like terms because the variable part, the y squareds, match up. If we wanted to add or subtract these, I would simply add or subtract the coefficients and keep the y squared the same. Second row, AB, 9AB, negative 15AB are all like terms. The reason they're like terms is because the AB, the variable part, matches exactly. If we were going to add or subtract these, I would add or subtract the 1, the 9, and the negative 15, the coefficients, and keep the AB the same. Third row, 5, XYZ, negative 6, XYZ, and 2/3 XYZ. All like terms because the XYZ variable part matches exactly. If I was going to add or subtract these, I would add or subtract the 5, negative 6, and the 2/3 and keep the XYZ the same. Examples of terms that are not like. 6x and 9x cubed. Even though they both have the variable x, one is x to the first power, one is x cubed, not like terms because the exponents do not match as well. mn squared and mn, not like terms because one has an n squared, the other one is just an n. A, B, and AB, not like terms because they do not all match all the way across the board as far as the variable portion. So looking at some examples, add the like terms. In this case, 6a squared plus 3a squared minus 4a squared. All three are like terms because the a squareds match up. So we simply add and subtract coefficients. 6 plus 3 is 9. 9 minus 4 is 5. And we leave the variable part the same. 2x plus 3y plus 6x minus y. Look at the like terms. 2x and 6x are like terms, so I can take 2x and 6x and add them. We get 8x. 3y and negative y are like terms. 3y minus 1y gives us 2y. 5x squared plus 3y minus 4x minus 2x squared plus 6y, like terms. 5x squared minus 2x squared gives us 3x squared. 3y plus 6y gives us 9y. Finally, we have negative 4x, which is not a like term with any of the others. So our final answer is 3x squared plus 9y minus 4x. Multiplying and dividing terms. This basically gets us back to our rules of exponents. When we multiply like bases, remember we add exponents, so x to the fourth times x to the fifth. Add those exponents, we get x to the ninth. X to the fifth over x to the ninth. Where do we have extra x's at? We have 5 x's multiplied in the top, 9 in the bottom. I have extras in the bottom. How many extra? 4 of them. Power raised to a power is when we multiply exponents. So here I take the 3 times the 4. We get a to the 12th. Product raised to a power, remember, is the same property as what we just had up above. I take each one of these powers and raise it to a power. Power to a power, we multiply. So we're going to get x to the 6th, y to the 8th. The last one here, quotient to a power. Same rule as what we just did. Each of these exponents inside get raised to the 3rd power. We multiply a to the 12th over b to the 6th.